Alright, so what should we do? I think there was a note that we should go on to other atoms. Is that right?
Yes, I think, yeah, we were going to change direction or whatever. Pivot over to a different topic.
Right. Oops.
Oh, I guess I didn't actually write it down. I thought I had.
Didn't we already start with the atoms? There it is. Alright, so there's this branch. I didn't push it yet, so I'll rebase it on the current main branch. Hopefully that'll be all good. And let's see what differences there are. Were we ready to send this as a pull request already?
I seem to think we were.
Alright, let's do that. So this touches standard types. Which would be in library std types. There's mixed arithmetic, right? So this used to be in the syntax documentation, but it's really runtime behavior of the built-in numeric types. So Python fully supports. So before this was a small note, right? Where a binary arithmetic operator has operands of different numeric types, the operand with a narrower type is widened to that of the other. Or integers narrower than the floating point. So instead of this, where integers narrower than a floating point.
Oh, I see. Now it basically it fails wide instead of.
We have this. And this built-in is added, since you can do anything you want with other types. So if both are complex numbers, everything's fine. If either is complex or floating point, the other is converted to a floating point. Otherwise, both must be integers. And in the int, float, and complex, I guess this is okay. This was probably taken from somewhere else, so let's see that when we get to it. Alright, in tokens, there was a note that keywords are also initially tokenized as name tokens. Changed to token value that indicates an identifier or keyword, because it's not initially, they just stay as name tokens, they don't get converted to anything else. And now for the main part. So, syntax notes. Instead of extended BNF notation, we have our grammar notation. And we left this note alone. We need to get to that Uh, I guess after we go through everything else. Now, arithmetic conversions. This had the 3 bullet points here, and now it just has a link to the runtime documentation. Should change this EG to, for example, right? Right, now atoms. Most basic elements of expressions. The plus are names or literals. So that's all of these. Forms enclosed in parentheses are also atoms. So this explains the whole thing here. And if I look at the diff, so that used to be identifier, literal, or enclosure. And the enclosure was parent form, list display, sit display, generator expression, and yield atom. I seem to have forgotten those. So this part is left as it was, because we didn't get to the parenthesized forms yet. Alright, built-in constants, true, false, and none, as well as the ellipses. This is the corresponding value, and several more built-in constants are available. That's should we repeat the link to the list of the several more here? Oh, see, it's just 3 more, not limited ellipses and under debug. Oh, and under debug is actually...
Okay. We're going through the feedback for PR 984, right? Is that right? Oh no, I guess it's...
Oh, is this already about feedback?
Is that right? I'm trying to figure out which PR are we working on now? It's this one.
So this isn't a pull request yet.
Oh, it is a pull request. Oh, I see.
The diff we have in a branch.
Okay. Oh, I see. We're doing real work. Okay, I see.
Send the pull request.
Yeah.
So this, I mean, you can see it in my branch on GitHub, but it's not a pull request.
Yes, I see. Okay.
So, okay, so this is weird. There's this debug thing in Python, which, what does it do? True if Python was not started with an O option. That's in here. And apparently it cannot assign to debug. How is that done? So that has the same behavior as assigning to the other keywords. But I guess under debug is not a keyword. So you can have can use it as an attribute name, or maybe a local? No, not local. Right, so it's not a full keyword, but you can't assign to it.
So it's a variable, is that right? Is it, or oh no, it's a, they call it a constant? Okay.
It's weird.
It is kind of strange, especially since it's, yeah, okay.
Right, so this of course you can do. You can do true equals false. Right? So there are several kinds of global variables like this. So you have something like print, which is available everywhere, but you can assign to it. So that's just a predefined variable. Well, that's a built-in you can redefine. Then you have debug, which you cannot assign to, but it's not a keyword.
Okay.
So you can do
oh, because it has a value, right? It's.
oh well, print has a value too.
Oh, I see. Oh, oh, okay. Oh.
Let's see.
So is it a Boolean? Oh no, it says there debug equals.
No, if
no,
I cannot assign to it.
You can't assign it. Okay.
Can't assign to it, but it's not a keyword. You can use it as an attribute name, for example. So if I do x dot true, that's a syntax error because true is a keyword. If I do x dot then do debug, that's a name error. Right? So debug is a valid attribute name, so this errors out on x not being defined. So this is somewhere between the cases of true and print. But apparently this is not handled at the syntax level, so let's not mention it here. Like a special support in the parser is there for debug as well.
All right.
Let's see where we handle debug in the C code. Symtable. Okay, so this is part of the parser. So there's a check name function that specifically handles under debug.
Oh, okay.
So you cannot assign to debug and you cannot delete debug. So to be pedantically correct, only the ones mentioned here are keywords. That's true. But only the ones mentioned here have special support in the parser is not true. So let's remove the part that is not pedantically true. Right?
What was the name of that file? You were looking at the C stuff earlier?
Symtable. Symbol table.
Okay, symbol table.
Symbol table. So this is the part that keeps track of variable names, basically. So if you assign to something, it makes it a local in the function or in the appropriate scope. which apparently is pretty complicated.
Yeah.
I don't know how much of that is optimization. I guess this would also take care of non-local variables, which is pretty complicated.
Oh, okay.
Anyway, it's a different level than syntax, so you don't have debug here, although it works in a similar way. Anyway, let's go on. So we left private name mangling as is. I don't want to touch that yet. Literals. So there was a big rewording here. Let's see, literal is a textual representation of a value. Python supports numeric string bytes literals. Formatted strings and template strings are treated as string literals. Numeric literals consist of a single. Ooh. This is weird. So does this link to the correct number? Right, yeah. Correct number token, yes. So where is this?
Oh, there's a token directive.
Yeah.
Not directive, field, I guess is what that is.
What's it called in Sphinx, right?
I think it's called a field in Sphinx, which is a weird name for it. But yeah.
I don't think it's called. Is it called a field?
The things between colons.
Yeah.
It's a Sphinx restructured text thing, I think. Field. Oh, no. Oh, is it field lists on the left? There, yeah, just down there. Is that it?
No.
It's not domain. I think domain is a different
Row.
role. That's what it is. A role.
Row name contents, yeah. Sphinx row.
Thank you.
So yes, there is a token role, but apparently you need to prefix it with the like whatever grammar it's part of, and that becomes part of the label. So you need to use this syntax. Hopefully that's correct. Yeah. Number token originates as integer blah blah. See numeric literals for details. String and bytes literals may consist of several tokens. See section string literal concatenation for details. Without negative numbers are syntactically literals, but expressions. There's some word missing here. operations involving the minus or plus operator. Valuation of a literal yields an object of the given type with the given value. Value may be approximated is a floating point in imaginary literals. All literals correspond to immutable data types, and hence the object's identities is blah blah blah. Yeah, I guess this is where we ended last time, right? This weird note on template strings.
Oh, I remember this. Yeah. Yeah, this is where we were wondering what to call the value of an interpolation. Can you compare templates? Let's see. No. Yeah, apparently templates compare unequal to each other if unless they're the same object, I guess. Was the equality operator mentioned in the t-string pep? That's pep 750. Template and import interpolation equality. Compare with object identity. Okay. So it is specified that templates and import interpolation are compared with object identity, which basically means exactly this, unless you have exactly the same object, Mm-hmm.
like this. Then they would compare unequal. Should these two be allowed to evaluate to the same object? Right, so when you do that with strings or any other literal, well, of course they're equal, but they're also the same object.
Oh, so we could use the word is?
And this is about specifying whether these can be the same object. Right? Now if you do x equals a very long string, and then you do y equals that same string, oh, you get the same.
Oh, because there it's comparing the value.
No, is comparing the object identity.
It is. I'm sorry. Yeah, is the identity. Okay.
So if you have a very long number, do you get the same? No. If you have a short number, then they are the same object. Why is that?
Wow.
Right, so this is a cPython implementation. Detail exactly which of these objects can evaluate exactly the same thing, and that's what this is saying. Right? Multiple evaluations of literals with the same value, either the same occurrence or the program text or different occurrence, may obtain the same object or a different object with the same value.
Oh, I see. So basically, you sort of have to ask yourself in a given situation whether you're more interested in the value or the identity.
Well, with these types, you should be interested about the value only. That's, the object's identity is less important than the value.
Ah, okay,
right?
okay.
Problem is this says all literals, which means it applies to template strings. And template strings are just weird.
Yes.
Template strings are sort of immutable, but they're not deeply immutable. They can contain mutable values. And you can have a list, and you can put it in a template. And no. Like this. And you can change the list. And that of course changes the template, because that has a reference to the list, right? So it's like tuples in that the template itself is immutable, but it can contain mutable objects.
I see.
So what I could say right here is simply each evaluation of a template string results in a different object.
Okay, that's I can understand that. It sort of feels non-controversial.
It doesn't it? The problem is, it is controversial. Because if I say this, I'm putting this in the specification of the Python language, which means cPython is now not allowed to make this optimization for template strings.
Oh.
And other implementations like PyPy or whatever are not allowed to do that either.
Oh.
That's the problem here.
Huh.
So that's why I'm putting this in implementation detail. In cPython, each evaluation of templates string results in a different object. Right?
Right. Okay.
Which is fine, except I'm not really saying why. And I'm not putting it in like the definition of the Python language. Right,
So maybe this isn't there like a an article all about template strings? Or perhaps I'm thinking of the free threading. I seem to recall they were working on something for template strings.
I mean, we could put it there, but then we would need to link to it, so...
Oh, yeah. Yeah, okay.
What I could also say here is all literals except template strings correspond to deeply immutable data types, and hence the object's identity is less important than its value. Multiple evaluations of literals with the same value may obtain the same object or a different object. Leave it like this and put it for this in a footnote or something. Put it in parentheses. Will that work? I know parentheses are frowned upon, but if I make it
yeah.
if I make it a note, it'll be too jarring.
And why would we need the parentheses? Because it's a
note you shouldn't really care about if you're
yeah.
not a language lawyer.
Yeah. Maybe say something like as a peculiarity, or as idiosyncrasy, or I seem to be struggling finding words today.
Okay, so one more thing that would be nice to somehow encode in this is this same value is for the purposes of this sentence, right?
Right. I don't know, maybe a note isn't such a bad idea. Or like an info. Maybe there's a...
I really don't want this to be too this is much too prominent.
It is, yeah. Is there a different admonition that might be a little bit less,
Footnote.
Oh, footnote.
Yes. Or parentheses.
Oh, shit, okay. Well, we wouldn't want the PR to get delayed because of something like that, right? Oh, and when we say rule, okay, got it. Oh, okay. In fact, we might not even need the parentheses now. What do you think? Because you sort of contextualized it.
What were your suggestions about the quirks of template strings? Yeah, this situation's a bit more complex for template strings.
Hmm. Do we want to have a subsection, or like a 6.2.3.1 for template strings?
Now I want to have a subsection for
I think we're down 3 levels deep, right? 6.2.3? Maybe 6.2.4? Oh, literal. Okay. Literal is an object identity. Ooh, that's nice. That's has a nice kind of academic flavor to it. Yeah, that's cool.
We have like deep immutability in the glossary. That would be useful.
I guess not.
Well, maybe we should add that. Deep immutability.
Yeah. I mean, if we're going to use the term and it has a specific meaning in Python, we probably want to put it
Or we
in
can
glossary.
explain it here. I mean, if we're not linking to it from 3 places.
Sure, because it doesn't show up anywhere else, right? This is the only place where we have this kind of hybrid.
Let's say template strings are immutable but may contain
Mutable objects.
reference mutable objects in as interpolation values. Strings.
Oh, the identity of the value.
Yeah, that's what I meant here.
Wow.
And now we can do the
Implementation. Okay, that's cool.
whatever I had here before. I guess I lost it already. previous paragraph is useless. I would. Should we have an example and an implementation detail? This is kind of dense, right? So.
Oh, okay.
This, but if you have. Oh, these are true. Okay.
Oh, that's kind of cool. Yeah, that would be nice to put in the code examples. Oh, that's right. I seem to remember that some of the small integers have they're like pre-constructed or something. They're like
yeah, they're that's an optimization because small integers are very, very common. So cPython doesn't need to allocate a new object every time you use the number 3. But it does have to allocate a new object every time you use 7 billion.
Okay. Change, yeah. Okay. Yeah. Change right. Okay, cool. May change. Oh, okay. Yeah, that's even better because it's more general.
I think we've changed it.
Yes, I seem to remember listening to a podcast about that. Yeah, cool. I have to say, for someone whose first language is Czech, you have a really refined familiarity with English. You're really good.
Yeah, only technical English though.
I see.
If you want to have small talk with me, I'll just be very introverted and quiet.
Mm.
And not get any of the idioms you're using.
Is that also true in Czech, though? I mean, is it like a personality thing, or?
Partly, yeah. It's
Okay.
much more pronounced in English. So comparing literals using the is operator. You shouldn't compare literals using the is operator.
Mm. Should we put a link there?
So let's see, if you do x equals 7 and then x equals 7. No, this is not. If is, sorry. Then you get a warning.
cool.
never
I don't.
remember which of these use abbreviations and which don't.
I rarely use the Python domain. Is within. Oh, there. Oh.
Right. All of this is an implementation detail, which is not very visible. Alright, this is a
Nice.
but it's not very clear how much of this is an implementation detail. So
Oh.
huh, should we enclose this in some box?
Well, if you made it a note, then it would show up as one big box, right?
As admonition on its own? An argument is required.
Oh. Oh. Oh,
This?
it's probably something indented.
Yeah, that's what I need to do. Can I have an admonition without
Oh,
without this?
do we have to put that there?
Yeah, that was the error. Admonition directive requires an argument.
Requires an argument.
Generic
Oh,
admonition with an optional
right.
title. Come on, it should be optional.
Oh, okay.
But it's not. One argument required.
Oh, note does not have a title, but admonition may take a title. Okay.
Yeah, note is just
Error, danger, caution.
okay, let's put it all in a note. I'll say note, which isn't really great.
Oh, it does. It will say note.
Yeah, it will say note.
Oh, that's a drag.
Can I put cPython implementation detail in a box?
What if we put that? Wait, if you do an admonition and you use the title as cPython implementation
So
detail?
can I put an admonition class on this? Let's see.
In other words, instead of... Oh, wow.
Whoa, that worked. Did that well and compiled.
Oh.
Nope.
Oh, but maybe that's because maybe it's because what if we did a ... admonition and then put in other words, instead of note, we called it an...
Oh.
Instead of note, we replaced note with admonition.
And then we put cPython.
And then say,
implementation detail in here.
Okay, we could probably move that down. I mean, that seems to look better, right?
This and the cPython detail as well. The example.
That's nice. Oh, we may want to just move that down a line. That's curious. Why is it taking detail?
What do you mean?
Do we want... Oh, okay. No, that's... For some reason I thought that the title would be on its own line, but that's fine. And then would we want to do something similar for the second, in the template string section down below?
No, that's just a single sentence, so I would keep that as it is.
All right. I think this is really cool. I mean, none of this was here this morning, a few hours ago.
And let's now call this section. Right, not sure how interesting this is, but I guess it's understandable now.
Yeah. I mean, it's thorough. You know?
Right. Now the question is this explained somewhere else in the documentation?
I don't know where it would be.
For example, a dreaded FAQ section.
Oh, I see. It might be. Okay.
We have the is operator. When can I rely on identity tests with the is operator?
Oh, that's great. Yeah.
Okay. There are 3 circumstances where identity is guaranteed. Assignments create new names but do not change object identity. After the assignment new equals old, it is guaranteed that new is old. Putting an object in a container and stored object references does not change object identity. Aha! After the list assignment is0 is x, it is guaranteed that is0 is x. Oh, this is actually this might be something that's not true in PyPy.
Oh, so that might vary with other implementations of Python? Is that what you're saying?
Well, it shouldn't according to the documentation.
Oh. Oh, I yeah. For some reason, I thought you said that it would be different in MyPy.
In
or
PyPy. I think they have some optimization where this doesn't always hold. Oh, I need to undo this equals none here. Make this a list of numbers, right? Yeah, still. I don't know. Okay, good. They might have something like this where they specialize lists of integers. So when you get something from that list, it might not be the same object. Apparently I cannot demonstrate it right here. But I think that's a reasonable optimization to make. Well, if cPython makes this optimization, I'll need to remember to point this out. Anyway, if an object is a singleton, it means that only one object exists. If A is none and B is none, then guaranteed that A is B. Okay, that's good. In most other circumstances, identity tests are inadvisable. Ah, that's a nice word. And equality tests
that's a great word. Yeah.
Do I still have?
I think we changed the yeah.
Yeah, we changed that, but we definitely want to link to this FAQ for more information. A is 1000, B is 500, C is B plus 500, A is C false. They're both 1000, but they're not the same object.
Should we use these same examples?
I think they explain it a bit differently.
Okay. Oh yeah, I see what you're saying. Yeah, no. It's we're trying to say something else.
C is false. So that's still the case.
This is really all about the nuances of the is operator.
Right. This is new instances of mutable containers. Oh, mutable objects in general. Oh. New instances of mutable containers are never identical. New instances of anything are never identical. The issue is when a new instance is created. So in library code, you will see several common patterns for correctly using identity tests. Is preferred for none. Detecting optional arguments can be tricky when none is a valid input value. In those situations, you can create a singleton object. Okay. Container implementations need to augment equality tests with identity tests. This prevents code from being confused with not a number. Right. Implementation of sequence contains if v is value or v is equal to val. Okay, we should link to this section. And we cannot link to it yet. Okay, so this is programming.rst.
Very nice.
Okay, so I hope this new section is done now. And we can move on. Now we have string literal concatenation, which basically stayed the same. Yeah, we didn't touch this yet in this pull request. Great. JSON strings are byte literals delimited by byte space. What? Delimited by white space? We don't have to delimit them by white space. Let's just get rid of this note. Don't need to have white space between those. This will work. Oh, I think we already rewrote this section.
Yes, I think so. Because
because this has your name in it.
That's a new example. Yeah.
So this should be good, except this delimited by white space. I don't know why we kept that there. the rest of this pull request will be adding links to converting to a common type. That's the mixed arithmetic section we started with today.
Oh, okay.
What was that? Like this one. This one. Alright, so whenever there's a reference to converting to a common type, we say numeric arguments are first converted to a common type, and the result is of that type.
Oh, I see. So we want to put in links to standard types.
Right.
Okay.
Its numbers are converted to a common real type, converted to a common type, and so on and so on. We need to get to we need to change these sections later when we get to them. But for now, I just want them to all have the link. Want them to have the link. And it says, the arguments must either both be numbers or both be sequences of the same type for plus, which is not true. Eventually, this will say, this calls the underadd method, whatever it is. But that's for later. For now, we have all of the atoms except the parenthesized forms. And other enclosed stuff. Array expressions, yield expressions. That'll take the next month. Generator iterator methods are documented here. Oh dear. This is not something you should have in syntax docs. Anyway, for examples, there's generators. Yeah, no, we need to move that. But I think we're done for pull request.
That's really awesome. That's great.
So what did we change? Fix-ups and an identification. Push with force and send the pull request. So this is the same. Something here.
Nice.
So this is syntax notes.
Yeah, and we added we elaborated on literals.
Then we had built-in constants.
Oh yeah, built-in constants.
And literals. to
standard types. Mhm.
oh, and we changed the name. We didn't do anything with identifiers.
I think we skipped the name mangling.
Yeah, we skipped all of identifiers.
Okay.
Right. Let's do this. And that means we should move on to parenthesized form. Well, either parenthesized forms or identifiers. Which is more interesting for you?
Yeah.
Parenthesized forms? Well, enclosed forms. So let's look at the current state. Parenthesized forms. Well, okay, this is the enclosure thing. Parenthesized forms, list displays, text displays, generator expression, and yield atom. So the parenthesized form is stuff in parentheses. And this says, if the list contains at least one comma, it yields a tuple, otherwise it yields the single expression that makes up the expression list. That's not pedantically correct. So, if you have 1 plus 3, for example, it's not a tuple. If you have a comma here, that makes it a tuple. But if you have more parents in there, there's no tuple to be found, even though the list contains at least one colon, right? So pedantically, this is incorrect, right? And we should write the documentation so that it's correct.
Yeah.
But if you read it, you shouldn't have the impression that we're kind of forcing it to be correct. So reword this entirely. So let's start a new branch. That'll be expressions parenthesized. And let's look how the actual grammar looks for this. Do we have, well, whatever it's called, parent form? We don't have parent form. So this should be Adam or enclosure. So yeah. For Adam we have tuple group and gen x. So we have tuples and groups, and they're separate.
Oh.
Which is great.
I guess.
Yeah, that's great for us.
Oh, I see. Because then we can talk about the tuples and talk about groups.
Yeah, we can split it into two sections.
Yeah. Nice.
So let's do that. There'll be a minor conflict with the other pull request here, but that's fine. Where are items? So this enclosure. Well, let's partially do the change we made here. And we'll need to fix the conflict when we merge the other pull request. Okay, enclosure.
Oh, I see.
It's like this. And now let's make it fit the grammar here. So what I'm doing for the docs and what I want to stay in the docs is put an enclosure here.
Mm-hmm.
And split it like this, basically. Right? This looks much better in the docs. I cannot do this in the actual grammar though, because this is less performant. Right? But having a rule like this is bad. What I am allowed to do when I ask the grammar or the parser maintainers on the Corda sprint is I can add some kind of annotation here saying, for example, inline, right? And then add code to Python's parser generator to look for this annotation and replace all the occurrences with the contents here.
Oh.
Right? So that's what I'd like to do eventually. But the plan is to change the docs first to match the grammar as it is. And after that, after we go through the whole reference, which will take another 5 years, then we go back and try to generate things, right? So that's the current plan. So this is the parenthesized stuff, tuple group and generator expressions. And we go to here, and that's parenthesized form generator expression. Is it? Yeah, the generator expression. And yield atom. Ooh, where is that? Where's that here? Oh, maybe it's part of the. Oh, it's part of the group. Ah, right. All right. So instead of parent form and generator expression, we say this, and maybe we can add a comment here.
Oh, I see. Yeah, they're not yet done in the grammar. That's a big change. Oh, okay.
Can we do that? Almost. Oh, it would be nice to mark this up, right?
Oh,
As a comment.
you mean like make it italic or something?
Yeah, whatever the class is. Make it like this, right?
Oh, there is a class for that. How about that?
It's class C1.
See, really? Okay.
Yeah, the syntax highlighting class names are very short.
No, that's cool.
Where do we do that?
Hmm.
I guess we need
Oh,
it
is it a-
in...
Is there a role? Is it like colon class?
No, that's the extension we made.
Oh, okay.
So we do comment.
Oh, how cool.
For a regular expression, and then we need to handle it somehow. Handle matches, RE group name, content. Oh. Oh, rule name, rule ref, snippet string node. What is snippet string node? Ah, so we need the same thing but for snippet comment mode. And it will have class C1, which is the pigments highlight class 4. I guess we need to search for that to get the comment correct. Do the pigments documentation contain C1? No. Comment single, that's the one. Hopefully. Where do we figure that out? There should be like a style sheet for this, right? Styles, pigments, C, comment, C1, comment single. Ah, here it is. So it is comment single. C1. Right, and this snippet comment node now needs to go here. undo it. Maybe I need to refresh the source. There we go. Right, so
Wow.
this is no comment. There's another thing.
My mind is blown. That's amazing.
Yeah, I still remember how we made this thing.
Yeah.
It's not the first parser I wrote. We need to do one more thing, and that is to put it in the meta documentation.
Okay, I see. Nice.
Now we have comments available for use. And we can go back here. So we should probably put group first.
Yeah.
And then tuple and generate expression.
Yeah.
Previously this was named reference expressions generator expression.
Oh,
and
I
that
see.
is
Generator.
a much nicer name than Exp.
Yeah, it is. Yeah. Oh, very cool.
And group and tuple, those were named parenthesized forms. And we're getting rid of this section and splitting it into two sections. One for group and one for tuple.
Oh, nice. I see.
So, parenthesized. Parenthesized groups, and I guess since we have list displays, sets displays, and so on, we should call this tuple displays. There's also a section currently called displays for list sets and dictionaries. Where either the container contents are listed explicitly, we have that for tuples, or they are computed via a set of looping and filtering instructions called a comprehensions. We don't have tuple comprehensions in Python. So we'll need to do something about this section. I guess this all is about comprehensions, so we'll need to change that up somehow. So all of this is old content. I get a comment, and Let's look in the grammar for what a group is. What are we trying to document? So group is parentheses and then a yield expression or a named expression. Okay. Yield expressions in the current docs, where are those? Oh, this is the yield atom.
Yield atom. Yield expression.
Yield
Okay.
atom. Oh, it has yield expressions in there. Okay, great. So yield expression is current rule we can just use, and we can get rid of this yield atom thing.
Oh,
and
cool.
Remove it
I see.
from the atom stuff as well. Huh. Wait. So we have. It would actually be nice to keep the yield atom here. Like make it distinct from
Yes.
the parentheses, right?
Yeah.
All the way on this level.
Oh, cool. I see what you're saying.
And now what's this named expression? If I go back to whatever the groups were, so this can be a start expression. Start expression can be an expression. Oh, I know what named expression stands for, right? That's where we can look in the grammar here for that. Name expression is an assignment expression or a non-assignment expression, basically.
Yeah.
So we need to find out how the current documentation calls these. So this is assignment expression. So instead of name expression, we have assignment expression in the current docs. Let's there we go. And now we say a group.
Oh, I see.
Group. is an expression enclosed in parentheses. The value of the parenthesized group, or the parenthesized group evaluates to the same value as the expression inside. Groups are used to what?
Collect?
For priority.
To associate? Collect?
Precedence.
Oh, I see.
Name for this.
I did not know that. Oh, okay.
Operator precedence.
So you can override. I see.
For example, let's you can do 3 plus 2 times 4, or you can do 3 plus 2 times 4, or you can use the parentheses here.
Oh, okay. That's a great example. So awesome. Yeah.
And yeah, you can use that for weird operators like this. Should I put in this example? Just to make it clear why we would want to clarify.
And it's a big difference too. Yeah, I like that example. let's see, left shift.
Right? Yeah. Is it?
Oh,
Is it not
okay.
left shift? Shift. Oh, right. This. Right, so the addition's in the parentheses, so we should put whatever's in the parentheses right here, right?
Oh yeah, of course. Do you capitalize or when you say it's bitwise?
No, I don't.
No? Okay.
Should I?
Okay, that's fine.
Oh, this is capitalized. Okay. I don't know where that convention comes from.
Oh, for clarification.
Oh, I could just say.
Uh-huh. Oh, okay.
Well, personally, I can never remember the preference for these.
Yeah.
I don't know. Maybe if I did bit operations the whole day, I would remember. But so whenever I get the chance, I put the parentheses in, and I don't have to worry about it. Okay. Do we need to pluck anything else from the original? Empty pair of parentheses. Yeah, we can
yeah.
do that. Note that tuples are not formed by the parentheses. Oh, right. This'll be interesting for later. Yeah. Let's keep it like this, and we're over time already, so I'll commit this. Start on enclosure. closures, put in all the good people who joined today, which is you.
Very nice.
Put it in my branch in case anyone wants to take a look at it. And
Yeah.
we'll continue next week. Thanks for joining. See you.